Dear Professor Sudeep, welcome to the project presentation on object tracking robot using Raspberry Pi and camera. We are a team of three, namely Rouble Malik, Vasant Ramaswamy, and Vishwanath Sangale. I am Rouble Malik and I will be giving a quick introduction to the project, project description, and description on various hardware modules used. With the advancement in technology like Internet of Things, embedded systems are increasingly being used in numerous applications. Raspberry Pi is a low-cost, bare-bone embedded system which are capable of performing high computation like running high-level operating systems. Example of Raspberry Pi can be in home servers, security, basic embedded projects used for educational purposes. We have implemented a mobile robot which tracks a predefined circular object. We use a Raspberry Pi camera mounted on the robot chassis. We have used hop transform and canny edge detection to identify the circular object like a tennis ball. We have used the Raspberry Pi as the embedded system and used the OpenCV library for the implementation of hop transform. We have used Python as our programming language, which is compatible with Raspberry Pi as well as OpenCV. Now talking about the hardware module used in our project. Raspberry Pi is a basic computing system. It has only the basic features required for any computer. We have used Raspberry Pi Model 1B+, which has processing speed of 700 MHz, available RAM of 512 MB, micro storage which has maximum capacity of 32 GB. It has features connected to peripherals like Ethernet, HDMI, 4 USB ports, camera interface port, display port, and general purpose input-output port. Raspberry Pi is small in size with low power consumption and moderate processing speed. For object detection, there is Raspberry Pi camera called Raspi camera. We have used this Raspi camera connected through camera serial interface to the Raspberry Pi using 15-way ribbon cable. This camera can be accessed using open source APIs such as MMAL and V4L. There is also a library called PyCamera developed in Python that we have used in our project implementation. There was also an option of using USB camera, but as USB camera increases the computation of Raspberry Pi, we avoided using it. The camera module of the Raspberry Pi can be used to take photographs as well as high definition videos. Applications like time-lapse, slow motion and other video effects can be achieved with the camera module. Camera module has fixed focus 5 megapixel camera that support VGA 90, 720 pixel at 60 frames per second and 1080 pixel at 30 frames per second video modules. For the motor driver of our robot, we have used Pololu dual motor driver. This motor driver is capable of providing 1.2 ampere continuous current. It is also capable of providing a peak current of 1.5 amperes with a maximum operating voltage of 11 volts. This motor driver can be mounted directly on Raspberry Pi module. For our project implementation, we selected the Magician chassis as our robot platform. This chassis has features like 2-gear motors with 65 mm wheels, a rear caster, 4 slots for AA battery holder. This chassis is also capable of holding peripherals like sensors, controllers, and power unit.
Dear Dr. Sudeep, this is Vasant Ramaswamy and I'm going to explain the software part of the project. I'm going to start by explaining the block diagram of the robot. We have a Raspberry Pi camera mounted on the robot chassis. It communicates using the camera serial interface with the Model B plus Raspberry Pi module. The model B plus computes the Huff transform and the canny edge detection. The basic idea in this project is to find the center of the object and align it with the center of the image. The module uses the OpenCV library to perform Huff transform and canny edge detection. The code is developed in Python, and the, the model provides the signals of varying magnitude and direction to the polylume motor driver. The motor driver then supplies the power to both the DC motors. The DC motors are supplied power by using 4 AA batteries connected in series. The motors are physically connected to the wheels. OpenCV is an open source library for computer vision. OpenCV has heavy computational requirements. In this project, we have successfully installed OpenCV in a Raspberry Pi module. It took us quite some time to install OpenCV on our Raspberry Pi Model B+. OpenCV is not actually designed to be used efficiently on the Raspberry Pi module, but we have demonstrated that it is indeed possible to install and use OpenCV on Raspberry Pis. The RGB video feed is received from the camera. This is first converted into grayscale. Before applying the Huff transform or canny edge detection algorithms, it is necessary to smoothen the image to remove noise. The primary purpose of using the Gaussian filter is to reduce the detection of false positives. A Gaussian filter blurs or smoothens the image by using a Gaussian function. We have used Huff transform in our project. Huff transform is a feature extraction technique used in computer vision and image processing. Huff transform can be used to isolate features of a particular shape within a given image. In our project, we have used Huff transform to detect circular objects. From the detected circle, two key parameters are identified: the xy coordinates of the center of the object and the radius of the circle. The x center and y center define the center of the circle, while r defines the radius of the circle. Removing noise from the image is important before performing edge detection algorithm. This is because edge detection is susceptible to noise in the image. We have used canny detection in our project. Canny detection has two key features. The first feature is non-maximum suppression. A full scan of the image is done to remove any unwanted pixels which may not constitute the edge. The second feature is hysteresis thresholding. This is the final stage which distinguishes between the real edges and the ones which are not.
Hello Professor Sudeep, this is Vishwanath. I am going to explain the detailed implementation of the algorithm. The algorithm designed for image transformation used to detect the circular object in an image. First, we have captured the original RGB color scale image using Raspberry Pi camera. Then, we have converted this RGB scale image into grayscale image, since it is easier to detect the borders in grayscale image. It also reduces the computation overload of the color image. This converted grayscale image is given as an input to Gaussian filter. Gaussian filter smoothens the image, which reduces the noise but also loses the sharpness of the image, which makes it easier to detect the real edges in the image, distinguishing false high-frequency pixels. Now, the output of this Gaussian filter is given to the Huff transform to detect the circular object. As we can see in the image, the detected object and its center. Now, we have detected the circular object. Now, we need to track the object. For tracking the object, we have designed a robot movement calculation algorithm, which has been explained in the diagram. The orange color object is the detected object in the image. The hub transform identifies its center and the coordinates of its center and its radius. We have calculated the center of the image by the resolution of the image captured by the Raspberry Pi camera. The image has been divided into 4 quadrants by considering the center of the image as the origin. Then, the distance between the detected object's center and the center of the image is calculated by using the Euclidean distance formula. The angle theta is calculated to determine the direction in which the robot should move. We are trying to align the center of the detected object with the center of the image so that ultimately it will track the detected object. Now, the speed of the robot is directly proportional to the distance from the object center to the center of the image. We have used different multiplying factors to provide the necessary torque to the wheels. During the course of our project, we faced numerous issues which we ultimately overcome to successfully complete the project. The first issue was the issue of false detection. Because of the limitation in the camera quality and the image computing ability of the Raspberry Pi module itself, the algorithm detects multiple false positives. To eliminate this, we have constrained on the radius of the detected object so that we can detect only the predefined object. The camera detects multiple false positives if the background is not smooth. Initially, we face a lot of problems because false positive lead the robot astray. But once we identified the problem and debugged the code, then the robot received a clear directives to move. The next problem was compiling the OpenCV on Raspberry Pi. OpenCV is very enormous library which took very large time and failed few times because of the dependencies on the other libraries. But ultimately we were able to compile the OpenCV library on Raspberry Pi. As we are dealing with the image computation algorithms in our project, it is very important to visualize the output from the camera. So we needed a GUI to see the actual output from the camera. To connect the Raspberry Pi GUI remotely, various network instructions were executed and the tools like PuTTY and Xmig were used. Since Raspberry Pi is made in the United Kingdom, the default keyboard setting was UK keyboard. This caused some confusion initially when we were writing the code with special characters. Finally, in this project, we have successfully implemented object tracking using Hub Transform on Raspberry Pi. The robot module developed is able to detect circular objects of different sizes and shapes within a certain range. The robot is able to identify any changes in the position of the object and follow the object. Despite the heavy computation required for image processing, the Raspberry Pi module is able to execute the program successfully. But observation is that response time of the robot is poor when it is doing high computation, which introduces delay in the response of the movement of the robot.